Alright, welcome to the next lesson. In this lesson, we're going to be talking about parallel and perpendicular lines. Okay, so we'll start off with parallel lines. So what do you guys think parallel lines are? Obviously, they're two lines that kind of go right next to each other, kind of just like that. So they have the same sort of slope. Okay, and what I mean in terms of what we've been learning so far, what sort of gradients do you think both of those lines have? Well, parallel lines, if I draw an example here, can see both of these are parallel. What do you guys think you can say about the gradient of both of those lines? Let's say the gradient of the first line is m1, okay, and the gradient of the second line is m2. What can we say about those gradients? Well, you can say that these gradients are going to be exactly the same, right? Because of the same slope we said at the start. So this is pretty much gives us our rule for parallel lines, okay? The rule for parallel lines is m1 is equal to m2, okay? That's our rule for parallel lines. m1 equals m2, all right? Let's do a couple of questions. So, are these two lines parallel lines? Okay, let's look at it. So the gradient of the first line is, well, it's going to be 3. So we can say m1 is equal to 3. All right, yes. Next, m2 is also equal to 3. Right? Then because m1 is equal to m2, which is our parallel line rule, we can say these are therefore parallel. Parallel, okay? Let's look at another example. Okay, I think you should pretty much tell straight away the gradient, but I'll do it. So gradient of the first line, m1 is equal to negative 1 over 2. And m2, okay, m2, the gradient of this one is 2. Okay, obviously we can easily see m1 is not equal to m2, therefore not parallel. Okay, parallel lines, really simple. Okay, it's a little bit more complicated with perpendicular lines. Okay, so firstly, let's talk about what is a perpendicular line. Well, it's any two lines that make, when they intersect, right, when they intersect, so when they touch each other, right, they make an angle of 90 degrees when they touch each other. That's what a perpendicular line is. Okay, now rule for a perpendicular line, it's not as obvious as a parallel line, and the rule is this. Okay, and there's a couple of rules. The first rule is this: m1 times m2 is equal to negative 1. Okay, that's a rule. You just need to memorize it. Okay, so pretty much saying if you get the gradient of the first one and the gradient of the second one, and if you multiply both of them, and if they equal 1, then yes, both of those are perpendicular, my bad. Okay, I can also rearrange this equation, take m2 to the other side, and I can say m1 is equal to negative 1 over m2, right? So pretty much this is how we get our perpendicular gradients. We can say perpendicular gradient of any graph is negative 1 over whatever your original gradient was, right? So this is equation number 2 and equation number 1. We'll probably be using 2 most of the time. Okay, I'm giving you both of them just so you have it. Okay, let's go on. Again, the exact same graphs, okay? So again, let's get the gradient of both of them. So m1, the gradient of the first one is equal to 3. m2 is also 3, right? But we can see that m1 is not equal to negative 1 over m2, right? Right, we saw. This is the rule we saw, okay? Or you can even do m1 times m2 is not equal to negative 1, right? You can use the rule number 1 as well. Doesn't matter which one. So you can say, therefore, not perpendicular. Okay, that's a symbol for perpendicular. I can't be bothered writing it down. Like I said, I'm pretty bad with English. Also, I'm just lazy to write it down. Okay, let's look at the second graph though. Again, it's the same one I gave you before. m1 is equal to negative 1 over 2. And m2 is equal to 2. Okay, what do you guys think? Are these perpendicular? Well, let's see. All right, so is m1 the same as negative 1 over m2? Is it the same? Let's look. m1, so m1 over here is negative half. Is that the same as? So negative 1 over m2 is 2, right? So obviously you can see the same, right? It's the same. So if it's the same, then this rule checks out. So therefore, these two are perpendicular, right? It's as simple as that. Okay, so remember 2 rules you need to memorize. For parallel lines, m1 is equal to m2. For perpendicular lines, it's either this rule, m1 times m2 is negative 1, or the perpendicular gradient is equal to negative 1 over m. Okay, so 2 rules. All right, so it's your turn. Okay, tell me if these pairs of lines are parallel or perpendicular, or it's neither of them. There's a chance that the 2 graphs don't have to be parallel or perpendicular, so it could be neither. All right, so pause the video and have a go. Okay, we'll go through it now. So firstly, let's do part A. So gradient of the first one, m1 is equal to negative 4. Gradient of the second one, m2 is equal to 1 over 4. Okay, what do you guys think? Well, let's do it. I can say that negative 4, right? And I actually, to get a bit more space, guys, I'm going to copy this down. I'm going to copy this down because we'll do a bit of working out for this question. Okay, so we have m1 is negative 4 and m2 is a quarter, right? So what we can say, you can say, well, this one, I'll do the first equation. Negative 4 times 1 over 4, so m1 times m2 is, well, it's negative 1, right? So then, yes, that checks out. Well done. So therefore, we can say they are perpendicular because equation number 1, m1 times m2 is negative 1, that checks out, okay? So we can say they're perpendicular. I'll also show you the other way around. So I'll use the equation m perpendicular is negative 1 over m, right? So m1 is negative 4. So negative 4 is equal to negative 1 over. So m2 is 1 over 4, right? So this is nothing but negative 4 is equal to negative 1 divided by 1 over 4. Well, how do you do division? You need to flip it and multiply. So negative 4 is equal to negative 1 times by 4 over 1. So I just flip the fraction. Well, then you can see clearly negative 4 is equal to negative 4. Right, again, so therefore they are perpendicular. You can say it like that. Okay, let's do the next question. What is the gradient of the first one? Remember, gradient is not 5. We talked about this in the gradients lesson. It's a number that multiplies x. In this case, is 1 over 5. Okay, and obviously you can see in this one is much even easier to see. m2 is equal to 1 over 5. So you can see this and this are the same. m1 is equal to m2. So what are they? We can say therefore they are parallel. Parallel, same gradient. Okay, let's do this last question here. C. Okay, C, what do you guys get? Okay, the answer I'll tell you is it's neither, right? Because let's look at it. So m1 is equal to negative 2 over 3 and m2 is equal to 2 over 3. Well, they're not the same, so because negative and positive, so they can't be parallel. Let's see if they're perpendicular. Right, let's use the first rule. So m1 times m2 is 2 over 3 is equal to, is actually negative 4 over 9. So it's not negative 1. So therefore, it's not perpendicular either. Well, if it's not parallel and it's not perpendicular, then it has to be neither. It has to be neither. Okay, that's it. All right. I actually have more questions for you to do. Okay, and I didn't exactly teach you how to do these questions. But why don't you pause the video, and we have learned all this, by the way, you should know how to do it. Why don't you pause the video and have a go at these questions. Okay, let's do it though. I'll walk you through the first one, part D. Okay, so part D. So again, we need to get the gradient of both graphs. The process is the same, all right? So how do you get the gradient of this graph? Well, we learned it in the gradients lesson, right? We need to make y the subject to get y is equal to mx plus c form. We learned this in the gradient lesson. So what I'm going to do is take x to the other side. So I get 2y is equal to 4 minus x. So subtract x. And y is equal to 4 minus x. Divide the whole thing by 2. Okay? Again, because we have a fraction, we need to split up the fraction. Y is equal to 4 over 2 minus x over 2. Right? So what's the gradient of this graph? Well, m1, the gradient is the number that's multiplying x, is actually negative 1 over 2. Alright, so let's rearrange the graph to make y equals mx plus c to find the gradient. Okay, so m1 is negative 1 over 2. Well, this one's much easier. What's m2? Well, m2 is equal to negative 1 on 2 as well. Right, so the same. So if m1 is equal to m2, what do you say? Therefore, they're parallel. Okay, you can even write m1 equals m2, then you can say therefore parallel, just to show proof. Okay, so that's part number 1. Alright, let's do E. Okay, E is much very similar to the first one that we did. Okay, so if you didn't get E, why don't you pause it again and have a go using this method. Alright, so again, to find gradient, you need to make y the subject, so you can have y equals mx plus c. So I have negative y is equal to 5 minus 3x. And remember, we talked about how to take negative to the other side. Take the left side, multiply by negative 1. Take the right side, multiply by negative 1. Negative y times negative 1 is y. And then expand the brackets. So you have negative 5 is equal to plus 3x on the right side. So we have y equals mx plus c. What's m1? Remember, m1 is the number that's multiplying x, which in this case is 3. And m2 is, again, we need to rearrange this equation to find m2 to make y equals mx plus c. So to make y the subject, I have 3y is equal to 7 minus x. Okay, y is equal to, now we have to divide both sides by 3. So we have y is equal to 7 minus x over everything divided by 3. Okay, divided by 3. So what do you have? Well, we need to split up the fraction. So you have 7 over 3 minus x over 3. So m2, in this case, remember it's a number that's multiplying x, is going to be negative 1 over 3. Okay, so m1 is 3 and m2 is negative 3. Well, they're not the same, so they can't be parallel. So then let's do the perpendicular test. Okay, so let's do m1 is 3 multiplied by m2, negative 1 on 3, right? Negative 1 on 3 is equal to, if you cancel out 3, is negative 1. Yes, so it passes the perpendicular test. M1 times M2 is negative 1. can say therefore these guys are perpendicular. So these guys are perpendicular. Why? Because m1 times m2 is equal to -1. Okay, I hope you got those answers. All right, so next set of questions, guys, a bit different now. So now we have to find the equation ourselves. So read this question. It says, find the equation of the straight line that is parallel to this graph, so parallel to this question, and it goes through this coordinate -2 and 5. Right? So let's think about it. Again, if you're finding an equation, we use again, to find the equation, what formula do you use? Y is equal to mx plus c. Right? Remember, step number 1 was find m, step number 2 was find c. Okay, that process is still the same. Okay, so let's do it. What is the gradient of this graph? How do you find the gradient? Well, you only have one coordinate. Remember, if you had 2, we could find the gradient, but you only have one coordinate this time. Well, let's think about it. If the question says it's parallel to this graph, okay, what's the gradient of this graph? The gradient of this graph, m is equal to 2. Right? So remember the rule for parallel graphs is m1 is equal to m2. Right? So if this is m1, what would m2 be? Well, it's the same thing. So the gradient, our new gradient of our new graph that we're trying to find is m2, or we can say m2 is equal to 2. Or you can even say m parallel. So that's similar for parallels, the two little dashes here. The parallel line is equal to 2. Okay? Remember, once you find the gradient, what do? You sub it into the function over here with x. So you say 2x plus c. Okay, let me just repeat that if you didn't understand. Well, the question is saying it's parallel to this graph, and the gradient of that graph is 2. And because parallel gradients have the same gradient, then parallel graphs have the same gradient, then we can say the gradient of our new graph is also 2. All right, so you find m. So then all you need to do is to find c. Okay, how do you find c? It's simple. We know this is the same as always. You sub -2 and 5. We only have one coordinate into this graph. So let's do it. So we have 5 is equal to 2 multiplied by -2 plus c. 5 is equal to -4 plus c. C is equal to 9. So the final equation is y is equal to 2x plus 9. That's it. Okay, simple as that. So this one's also very similar. Guys, why don't you pause the video and have a go. All right, let's do it. So so we have y is equal to mx plus c. Okay, so step number 1 is find the gradient. What's the gradient? Well, the gradient of this graph, m1, we can say is -2 over 3. Then what's the parallel gradient? The parallel gradient is going to be the same thing. Okay, so the new gradient, so m2 we can say, or is equal to m parallel. It doesn't matter which symbol you use, it's the same thing. Okay, is equal to -2 over 3, which you sub into this. So you get the equation y is equal to -2 over 3x plus c. All right, let's keep going. So step number 2 is to find c. So to find c, it's the same as always. You sub in the coordinate 9 and -10. 9, -10, which is, if you sub into here, y, remember this is y, this is x, y is going to be -10 is equal to -2 over 3 multiplied by 9 plus c. Okay, so then pretty much solve for c, -10. You can either times the top two and say it's -18 divided by 3, or what I like to do, remember, I love cross simplifying. So if I have this kind of 9 on 1, 3 goes into 3 once, 3 goes into 9 3 times. I can cross simplify. You're left with 3 times 2 is -6 over 1. So divided by 1 on the bottom, which is -6. Okay, plus c. And then add 6 to both sides. C is equal to -10 plus 6 is -4. So if c is -4, your final answer should be y is equal to -2 over 3 x minus, so what's the c value? It's -4, so it's -4. Okay, that's it. Simple as that. All right. So next step. Okay, this one's a bit different. So now instead of parallel, we have perpendicular. All right. If you guys think you know the answer, why don't you pause the video and have a go at this one. All right, let's do it. Okay, so this time it's saying it's perpendicular, not parallel. So step number 1 is always the same, is to find gradient for a y is equal to mx plus c. So this time, let's find the gradient of the original graph, m1. So m1 is equal to -2. Okay, so we're not finding the parallel gradient this time. We have to find the perpendicular gradient. Okay, and this time we can use I said this time like 3 or 4 times. I'm sorry about that. This time. I'll stop. That's the last one, I promise. Okay. So m perpendicular, what's the second equation we had? We had m perpendicular is going to be -1 over whatever the original gradient was. Okay, so if this one is the original gradient, to find the perpendicular gradient, you just sub it into here. Okay, so the perpendicular gradient is equal to -1 divided by -2. So the perpendicular gradient is going to be half. So that's the gradient of our new graph now. We found it. Okay, it's perpendicular, not parallel. Okay. So let's do it. So you sub half into our mx plus c. So our equation is y is equal to half multiplied by, do better, 1 over 2 multiplied by x plus c. So I'm replacing m with half. Then again, same as always, find c. This is never changed, it's always the same thing. So 2 and 3 sub into the original equation, the half equation. So y is 3. So 3 is equal to half multiplied by 2 plus c. 3 is equal to 2 over 2 plus c. 3 is equal to 1 plus c. I'm taking a lot of steps just in case. And subtract 1, so c is equal to 2. Okay, so your final answer would be y is equal to half x plus 2. That's it. All right. Again, a couple more questions, guys. Why don't you... this one's a little bit different, but have a go at the D and E. Okay, so E is different, but D is the same what I just did. Okay, have a go. Pause the video. All right, let's do D first. So again, it's the same thing. First step, find the perpendicular gradient, because that's what the question's asking. So if you first have to find the gradient of this graph. M is equal to 2 over 3. Okay, so it's a bit weird. So remember the rule was -1 over m is the perpendicular gradient. So you sub this 2 over 3 into here. So the perpendicular gradient is -1 over 2 over 3, okay? So we just need to simplify this a bit. It looks a bit scary, but it's really not. You just need to simplify it. So you can say m perpendicular is -1 divided by 2 over 3, right? Both of these mean the same thing. So remember when it's divided, you can flip it and multiply. So the perpendicular gradient is -1 times by 2 over 3, which is equal to -2 over 3. So that's the gradient of a perpendicular line. Oh, no, I'm sorry. I didn't flip it. I made a mistake. So remember, if you multiply, you need to flip it. So it's 3 over 2. So then the perpendicular gradient is actually -3 on 2. There you go. I found the mistake. All right, remember, guys, if you make a mistake and you realize it, go back and fix it, obviously. All right. So you sub this into y is equal to mx plus c. So y is equal to -3 onto x plus c, and then you sub in your coordinate, right? So y is -4, so -4 is equal to -3 over 2 multiplied by x is -6 plus c. Remember, you can cross simplify these questions if you want. So you can just multiply -6 and -3 if you want. I'm going to cross simplify because I find it easier. So 2 goes into 2 once, 2 goes into -6 -3 times. So you have -4 is equal to +9, -3 times -3 is +9, plus c, and c is equal to -4 minus 9 is -13. Okay, so final answer, y is equal to -3 over 2x minus 13. All right, that's it. All right, so this one's a bit weird. E is a bit weird. Okay, it's parallel to x equals 4. Right, that's what does that mean? X equals 4. This doesn't have a gradient. The gradient of this is undefined, right? So pretty much, guys, if you sketch this out, what does this graph look like? Well, this graph looks like this. Okay, x equals 4. Remember, we talked about sketching graphs in the previous lessons. So x is equal to 4 is here. Well, this is just a vertical line here. Okay, so pretty much what this question is saying, if it's parallel to a vertical line, it's going to be another vertical line, right? It's going to be another vertical line somewhere. Okay, it's just a vertical line, but it's going to be somewhere. We don't know. Could be anywhere on the graph. Okay, but it's specifying, it's saying that it goes to this coordinate, -2 and -15. So it has to go through this coordinate. Okay, so I guess you guys can kind of see if you just put it at -2, well, it will go through that coordinate. Okay, but you know, it's easy to see graphically. Let's just pretend that we don't have the graph, for example. How would you do this with that graph? Well, if it's parallel to x equals 4, then you know that it's at x equals a, right? It's still a vertical line. So a is just a variable that I made up myself, and a is the thing we need to find. Okay, and then all you have to do, so this is how you do graph without a graph. You can use the graph if you want, it's much easier. But if you want to do it with the equation, it's a better way to do it, I think. All right, so this is how you do it. So you sub -2 and 15, right? What is -2 and 15? It's saying x is -2 and y is equal to 15 is equal to y, right? So let's sub this in, okay? And you'll notice there's no y in this equation, so I can't really sub y, okay? So it doesn't really matter. What I'm going to say, it doesn't matter what the y variable is. You just need to sub x into x. So -2 is equal to a. So pretty much a is equal to -2. So in the graph of the parallel line is x is equal to -2. Okay, now I'm going to show you graphically again why it doesn't matter what the y value is, right? So if a vertical line has to go through -2, and let's say another coordinate is -2 and 10, right? -2 and 10 is up here. Up here would be over here, -2, 10. -2, 10, okay? And then it's going to be a vertical line through there, right? So you can see this vertical line goes through all coordinates, -2 and -4, for example, or -2 and -10, let's say positive 12, right? It doesn't matter what the y value is. If the x value is -2, it's going to go through all of them. All of the x values is -2. That's why it doesn't matter what the x value is. We don't care. Okay, I hope you understand. It's a bit messy, the explanation, that one, but I hope you understand. Okay, we'll do a couple more questions and have a go at this one. Okay, parallel to y is equal to -10 and goes to this question. Okay, let's do it. All right, I'll show you this graphically. All right, if you didn't understand this, the previous question, this will make more sense. So remember, y equals -10 looks like this. It's a horizontal graph, and it goes through -10, like so. So, and this has to pass through the coordinates 5 and 3. So 5 is here, 3 is there, has to pass through this coordinate. And then you can see graphically, well, it has to, if it's a horizontal line, it has to go through that graph, right? Well, the equation is y is equal to 3. Okay, that's how you do it graphically. But we'll do it with the equation. Remember, if it's a horizontal line, it will have the equation y is equal to a. A is a variable I made up. And then you just sub in 5 and 3. So x is equal to 5 and y is equal to 3. Okay, remember in this question, there's no x. So we don't really need to sub 5 in. So in this question, x doesn't matter. So you just sub y is equal to 3 into the graph. So you said 3 is equal to a is equal to 3. So the equation of the graph, you can see the same as what we got up here with the graph, is y is equal to 3. Okay, I hope you understand that one. Okay, use similar logic. Okay, it's perpendicular this time. Use similar logic to do these last two questions. Okay, have a go. All right, we'll do this one. So this time it's saying, okay, we have x is equal to 4. X is equal to 4. X equals 4 is a vertical line. Remember, it's a vertical line at 4 and goes to that. It's a vertical line. Okay, now it's saying it's not parallel, right? It's a perpendicular line. So what is a perpendicular line to a vertical line? Well, it's simple, guys. It's a horizontal line. It's going to be a horizontal line because remember, these two need to make a 90-degree angle, right? So that's what, if it's a perpendicular to a vertical line, it's a horizontal line. And this horizontal line, so we know for a fact it's a horizontal line, so the equation is y is equal to a. It needs to go through -4, -7. So -4 is here, -7 is all the way down here, so it has to go through that sort of coordinate there. So then this horizontal line needs to go through that coordinate. Then can you guess the equation of the line? Well, it's going to be y is equal to -7 graphically. But if you don't have a graph, we can do sub in with the coordinate as well. So you sub -4, -7 in to the equation. As we talked about, there's no x in this equation, so x doesn't matter. So if you sub -7 in, -7 is equal to a is equal to -7. So the equation of the graph, y is equal to -7. Okay, I'm showing you both ways. I'm showing you graphically. I'm showing you with the equations as well. All right, last question. So it's now similar. So it's similar to the one before. Now it's saying perpendicular to y is equal to -10. Y equals -10 is here. So it's a horizontal line. Can you guess what's perpendicular to a horizontal line? Well, it's going to be a vertical line. So it's opposite, right? It's opposite. So this vertical line, again, it could be anywhere. It just needs to be a vertical line to be perpendicular. But, okay, it needs to go through this coordinate, -½ and 18. So -½ is going to be roughly here. And 18 is going to be all the way up here, 18. So this is -½ and 18. So this vertical line needs to go through that coordinate, right? So you can see if you put it there, what's the equation of the graph going to be? Well, from the graph, we can see x is equal to -1/2. That's the equation of the graph. All right. So what do you have left? It's going to be x equals -½ is the answer, but I'll show you, of course, I'll show you the equation. X is equal to a. We made up the variable, and you sub in -½ and 18. So again, this is x, this is y. There's no y in this equation, so we don't need to sub in y at all. So then x is -½ is equal to a is -½ and then I can say x is equal to -½ is the answer. Of course, the same thing what we got. Okay, so I showed you two approaches. I find that the graphing, this approach up here is a bit easier because you can visualize it, so you can use that one if you want. But I'm showing you, if you're more like an equation-minded person, you can use the bottom one as well. Okay, so it's up to you. I'm showing you two different ways. All right, so that's all there is to perpendicular and parallel lines. I hope you understand everything. Remember, you can always rewatch the video if you didn't understand something. Okay, that's it. I'm done talking. I'll see you soon.